All right, welcome. Today, we're going to do something pretty cool. We're going to shrink ourselves down, like way, way down, to the subatomic level. Why? Because we're going to explore the fundamental building blocks of, well, literally everything.
So, what are the fundamental building blocks of everything? I mean, think about it. The air you're breathing right now, the device you're watching this on, it all boils down to this one tiny, incredibly powerful little thing called the atom. But what's actually inside one? That's what we're here to find out. It really all starts with just three key players. You can think of them as the main characters in this whole story: the proton, the neutron, and the electron. Each one has its own job, its own personality, and its own place where it hangs out. Okay, first up, let's dive right into the atomic nucleus. This is the super dense core of the atom. Seriously, this is where most of the weight and the real action is happening.
So, where do our three characters live? Well, the protons and neutrons, they're roommates, packed together right in that central nucleus. And the electrons, they're the energetic ones, just buzzing around on the outside of it all. Okay, so if you count up all the protons and all the neutrons that are crammed into that nucleus, you get a really important number. It's called the mass number. And really, it's just what it sounds like. It tells you the mass, or the weight, of the atom's core. Simple as that. Protons plus neutrons equals mass number. You know, to make this stuff stick, let's use an actual example. We're going to follow a single atom through this whole process, and we'll just call it atom A. So here's what we know. Atom A has a mass number of 40. That's our first clue. It means its protons and neutrons have to add up to 40. And here's our second clue for the puzzle. We're told that this specific atom has exactly 20 neutrons. So out of that total mass of 40, we know 20 of them are neutrons. So that leaves a missing piece, right? If the total count in the nucleus is 40, and we already know 20 of those are neutrons, what does that leave? How many protons does it have? You can probably figure this one out. And yup, the math is super simple. You take the total mass number, which is 40, subtract the number of neutrons we were given, which is 20, and what's left is 20 protons. Boom! Just like that, we've cracked the code of the nucleus. All right, we figured out the core. Now let's look at what's happening on the outside, the electron shells. This is all about balancing the atom's electrical charge. So here's like a golden rule of atoms. For an atom to be neutral, meaning it's stable and perfectly balanced, it has to have the exact same number of electrons as it has protons. It makes sense, right? The positive charge of the protons and the negative charge of the electrons just cancel each other out perfectly. Okay, let's connect that back to our atom A. We just figured out it has 20 protons. So, if we're dealing with a neutral version of this atom, how many electrons does it need to have to stay balanced? You got it, 20. It needs 20 electrons to cancel out the charge of those 20 protons. So there we have it, our complete picture of a neutral atom A. But things in the atomic world aren't always so perfectly balanced. What happens then? That brings us to charged atoms. So what exactly happens when an atom loses something and that perfect balance gets thrown off? So just take a look at this. On the left, that's our happy neutral atom A, where protons equal electrons. But check out the one on the right. This is what we call a positive ion, and you see it written as A with a 2+. And in this case, you can see the number of protons is now greater than the number of electrons. And this is a super important point, and it can be a little tricky at first. A positive charge doesn't mean the atom gains something positive. It actually means it lost something negative. So for our atom to get that 2+ charge, it had to have lost 2 of its negatively charged electrons. Let's just walk through that step by step. So step 1, our neutral atom starts with 20 electrons. Step 2, something happens and it ends up with a 2+ charge. So what happened? Step 3, it had to lose 2 electrons, and they always come from its outermost shell. Again, the math here is really easy. We had 20 electrons to start with in the neutral atom. It lost 2, so you just subtract those 2 lost electrons, and that gives us our final number. So there you have it. Our charged ion, the A2+, now only has 18 electrons. And because it still has 20 positive protons, but only 18 negative electrons, the overall charge is +2. It all adds up. Okay, we've gone through all the pieces. Let's put it all together now and look at the complete blueprint. This little table really lays it all out. Look at the protons and neutrons. For both the neutral atom and the charged ion, they stay the same, 20 and 20. Those guys in the nucleus don't change. The only thing that's different, the only thing that changed at all, was the number of electrons. And that really brings us to the single most important idea to take away from all this. The number of protons, that's the atom's identity. It's what makes it a specific element, like carbon or oxygen. That number is fundamental. But the number of electrons, that's what defines its charge. That's what determines how it's going to behave and react with everything else around it. So we've seen pretty clearly that when an atom loses negative electrons, it becomes positive. So here's a final thought for you to chew on. What do you think happens when an atom gains an extra electron? What kind of charge would it get then? Something to think about. Thanks so much for joining me.